Good morning, everybody, or good afternoon, depending on where you are. Welcome to today's DVT Insights session, where we have Chris Fourie joining us, and he will be covering data accessibility to unblock high-risk AI. Chris, we are fortunate to have on our team as our lead in the ML ops and ML data science space, helping organizations utilize AI solutions in order to build out really good solutions that basically meet the needs today in business. But more importantly, Chris comes with a wealth of knowledge in terms of the research space and the application of AI to high-risk endeavors. And by that, it's not your regular created chatbot. It's in the situation of where medical information might be involved, or where key IP might be involved, or where critical projects where decision-making is based on models and on the application of AI to make determinations that actually have consequence. And in that space, there's a lot to learn from this and bring across into regular projects in terms of how that applies and what to consider and how we might actually solve that kind of problem. Chris himself is a very bright young man with a world of experience in technology as well as the medical field. He also happens to be one of those fantastic people that is a do-gooder with the intention of helping communities and finding the ways that technology and access to information will improve the lot of communities and the people within those spaces. So with that, it's an absolute pleasure to welcome Chris today and have him actually present to you. Before he does so, just to give a reminder of how we run the session, Chris will present through the course of the morning. And at the end of it, we'll then do a bit of a Q&A session to answer your questions. If you do have a question and it occurs to you during the session, please raise that for us in either the Q&A function that you'll find available in your menu, or just through the chat window. I'll pick those up and then pose those back to Chris at the end of the session. And without any more delay from my side, Chris, welcome to the session. Thank you so much for giving up your time and sharing your expertise today.
Thank you, Carl, and I appreciate that very generous introduction. It's really great to be here today. I do enjoy talking on these subjects, and yeah, there's a lot to cover today. So it's quite an expansive space, but I'm excited because I think not everyone has the opportunity to engage in high-risk spaces, and I think there are definitely some learnings that I can share just from having carried through like a number of projects, trying to identify what topics are sort of most impactful, but also to provide context. So I'm going to try my best to pitch this both at a very high and general level, and then do occasional deep dives for those who have interest in technical aspects. However, if you see something on a slide that fills you with anxiety, please zone out for a second and come back when we've gone back to a little bit more of a high-level space. I've also very intentionally got probably more slides than necessary. The idea here is I'm going to be making the slides available after the talk, and those are really intended as breadcrumbs for the curious to be a starting point to explore in some of the various spaces that I'm going to touch on. And as Carl mentioned, I'll be taking questions at the end. Please feel free to ask away during the talk, and I highly endorse a participatory audience. So if you feel like you have an answer to someone's question, or you'd like to engage on that question, please do, and we'll moderate those at the end. So yeah, without further ado, hi, I am Chris. You can find me in some internet spaces with my handle, social handle at RoboBonobo. I have a medical degree and a master's in computer science from Wits University. I identify as a research MLOps engineer and a community builder. And a little bit about my journey, because I think in these spaces, it's not always a straight line. These careers tend to meander. So I think during my time as a medical student, I spent more time than I would admit, I guess, daydreaming and about solutions that can work at scale. So during the time, I also got involved in community building. I helped lead restarting the South African Medical Students Association and was the representative at the International Federation of Medical Student Associations, it's a mouthful, for about 2 years. So representing South Africa there. However, when I finished my medical degree, I went and did a master's in computer science. I did a brief year of a general engineering degree, but hot tip, don't ever do a first year, or at least try to avoid it, because all they're trying to do is teach you how to pass exams. And after 6 years of med school, I had enough of that. So my interest when doing my master's was at the intersection of computational neuroscience and AI, and how those can feed into each other, specifically in biologically plausible machine learning. I was looking at multi-agent RL and neurons. I've also, an impactful step there in my journey was the computational neuroscience in BISO. It's held in Muizenberg for 3 weeks. I highly recommend it if that's your thing. I'm also being involved with the Deep Learning Indaba and the Deep Learning Indaba X. I've been helping organize a number of the AI for healthcare workshops at both the local and international events. I helped co-found a Pan-African AI for healthcare community, Sisonke Basik. We recently won a best social impact paper at ACL. So that's Association for Computational Linguistics. I spent some time at a US startup, LifeQ, working on MLOps and research engineering for continuous monitoring. A lot of it was from wearables. So can you detect COVID from your smartwatch is a problem that I've worked on. I've also worked for the Western Cape government in their provincial health data center. I believe we have the largest patient cohort on the continent. It's about 8 million patients. I'm also a technical advisor on a project called Data Science Without Borders. It's a federated analysis across 3 years in facilities in Cameroon, Senegal, and Ethiopia. And more recently, I'm with DVT. Hooray! So yeah, what exactly is a research MLOps engineer? So all of these things to different degrees, but it's very multidisciplinary. This is a great paper, by the way, if you're interested in the space. If you want to know a little bit more, that's kind of what that touches on. And for the research part, I do that plus setting up the nature of a research project and also writing grants for funding, which is an important part of research that people often neglect. But yes, onto the talk. Accessibility to unblock high-risk AI. So what do I mean by high risk? It's anything as a potential for harm, either the data or the outputs from the AI itself. And how do we go about managing those? So let's start with the AI, because that is the hot topic. And by golly, there is a lot of hype, and there has been a lot of hype for a long time. So this is even from a survey in 2018. 63% of US managers in those companies reckon that they wanted to have AI as a product. However, while I am very pro AI, I also am very conscientious about looking very closely at the realities and how difficult it is to actually get it right. So trying to temper the hype where I can and where it makes sense. So just considering some of the evidence, and this was even sort of 2020, 2022, the survey found that there were only about 14 to 26% of widespread deployments for the company surveyed, and which is quite a lot less than what the expectation was there. So looking at an IBM Global Adoption Index, across 7,500 respondents. We can see in blue what's deployed, and in purple what the sort of expectation or exploration is. And there's just like a massive gap there. And I mean, to also note, like Africa is not even on this, no African country is even on this survey. So just looking at the global rates there, there is a gap. And I think it's important to note this gap. But then ChatGPT, maybe things have changed. November 2022, and if we look at historical, rates of adoption, ChatGPT rarely shines across these platforms. I mean, Threads does better, but they also were bootstrapped from Instagram, so I haven't included them here. So has this changed? I mean, does this mean that since ChatGPT, we are now seeing AI actually being deployed in production and having the returns they've been promised? This is a very recent report from August this year. MIT suggests that 95% of their surveyed individuals did not see returns. There are some stats on how many people were engaged with. So one of the things I like to mention quite frequently, actually, is that all models are wrong, but some are useful. And each of these pieces of evidence is just one view of the world. And even what I'm talking about today is just my perspective and my view on this. So understanding exactly what reality is very hard. Some might say impossible, but if a model is useful, then that is a start. So there's evidence to suggest that it is still quite hard. Lucky for groups like DVT, the evidence also suggests that success is more frequent when you're partnering with specialized vendors. So I think going through companies like DVT, versus doing this by yourself as a company is definitely a good approach. And we've seen this from various companies as well. So various AI companies looking at things like forward deployed engineers and building client relationships over dropping lots of money into foundation models as a business approach. And just to say, this comes from a really interesting initiative by MIT. If anyone's interested, to take a look. And what I'm trying to get at is that ML or AI, it's hard. It really is hard, and we're going to get into but why it is. And it's just a lot of complexity. And outside of just the complexity of the AI and experimentation and understanding what's the many different flavors of approaches and models can do and how they can break in very creative and frustrating ways that are just devilish to try and debug. There's also, your ML code is just one part of a very complex machine. And this paper is from 2015. It's a canonical paper in the machine learning operations world. And your code, your ML code, is embedded in this much larger complex system. There has been great strides, though, to simplify this, and the tooling and platforming has gotten a lot better. But that is just to mention that software is also hard. And all of this exists in a complex world. So let's look at Africa in particular. We have to deal with things like resource scarcity, in addition to these other complexities. So your lack of digitized systems, infrastructure, costs and funding, governance, regulation, ethics, capacity, fragmentation of efforts are all highlighted problems there. But just looking at the distribution of data centers, these are from the top 3 clouds, so AWS, Azure, and Google Cloud. There are, soon going to be some in Kenya and Nigeria, and this map is a little bit out of date. Just at a glance, you can see if we wanted to deploy something like Databricks in an African context to utilize all of that MLOps platform infrastructure, you're going to have a hard time doing that Good news, though, is that according to Papia, the GDPR is quite compliant. And what that means is if you can convince the data regulator that you can move your data, then data sovereignty becomes slightly less of an issue, given that you're able to and have the money and time to engage with the data regulator on this and then convince them of that. However, I think as a baseline assumption, you should assume that don't let sensitive data out of your national borders in whichever country unless you have a very, very good reason to, because it's going to be expensive and time consuming, so avoid it at all costs. But there are emerging routes to make that happen. However, also to note that there are other data centers in Africa that aren't those three big cloud providers. And I'm not going to linger on this, but I'd encourage people to check out this tool and just poke around and see what people are running on various different in different countries to see what their stacks are like. I think you'd be surprised at how innovative some African data centers are being. And then high-risk data is hard. And as you can see, I'm definitely stacking the complexity here. So just taking healthcare as an example, this is also very recent from September this year. The illusion of readiness, stress testing large frontier models on multimodal medical benchmarks. So what they're trying to say is even though these are doing very well in benchmarks, the benchmark isn't the real world. And when we do more in-depth fragility and robustness testing, the performance is not as good as initially anticipated for a number of reasons. This graph is a good indicator of that. So those are the benchmarks, the different shades of teal. And the red line is the robustness testing, just noting that these axes are different. So this is accuracy, and this is a mean robustness score. So you'd have to read the paper to understand exactly what the impact of that different axis is. But just at a glance, you can see there's a discrepancy between the red lines and the teal lines. And that should be at least concerning at a glance. So slight tangent here. If it is so hard, should we even try doing AI? I mean, if we are going to be doing this, should we, be given that our African context is so hard, should we just sit back and let someone else solve this problem who's better resourced, and then eventually we'll all get to a Star Trek-esque future? I mean, one of the reasons that I got into AI is because I deeply believe in its benefits to humanity, or its potential benefit to humanity, and all the really cool stuff that we'll be able to do if we each have our own robot friend. However, I don't think those kind of features are guaranteed, and we should be keeping an eye out on what's going on globally, as well as focuses on things like responsible AI tend to address this. However, also noting that these two options might not just be the reality itself. This could just be a false dilemma, and I think often this could be used, I say this speculatively, to raise funds for one's project. And often the world is way more complex with many more options in between. So just noting that. However, if we do look at what's going on with what Switzerland did recently, so this is September this year, also very recent, they rolled out their fully open international AI model. So they've got the Swiss LLM right now. And if I look at my crystal ball, then I think it's only a matter of time before we start seeing political parties having their own LLMs. And then, what is the truth starts to become an interesting topic of debates, especially when a lot of people tend to trust these things fairly implicitly. Anyway, back to our regular programming. High-risk data is also hard. And that's really going to be the main topic for today. And just for some insight into where we can see this at a glance, this is called a Wardley map. It seeks to try and quickly communicate your topics in a value chain where things are invisible to where things are very visible to the end user. So often, like, the end user will be at this ML service over here, and then the platform and the AI models and the data that sit in the background are fairly invisible. And often things start in this genesis space, and then as we invest more, you can think like solar panels started off very expensive, and then as we started to mass produce them, they move into the next column until they become a commodity. And data has canonically or famously resisted commodification, although we are seeing some interesting new data marketplaces emerging. So that is something to keep an eye on. And I hope that when it does get commodified, and I think it will be, that it's done in a responsible way, because high risk means potential for harm. So we do not want to be causing harm in any of the work that we do. But yes, this is just high-level evidence that data is a bit harder to commodify than models, or much harder, actually. I mean, today you can just go and pick and choose open source models off of a shelf and plug them into your solution. Data is very siloed, and some estimates are that we're only training on like 0.1% of the data we could be training on. So making this data more accessible is really a key problem that we're only, as a global community, starting to address at scale now. So yeah, high risk data. Why is this risky for your LLM? Well, or any AI product really, is because it sits upstream of your AI model. If you put high risk data and you train on it, for a number of reasons, this can make your model potentially cause harm as well. The good example there is just memorization, where your LLM can, or again, any model really, but in particular LLMs can just memorize sensitive information and then split that out when you least wanted to. And then there's everything within that pipeline or supply chain that's could cause harm. So I'm using fire here to describe sensitive data. It's a metaphor from a group called Open Mind. A little bit more on them later. People often call data like the new oil. They describe it as fire because as soon as you let it out of a box, you actually don't know how far it can spread. You don't know how it's going to be used or could be used in the future. So the same way for, let's say, like food, you'd want to maintain like a cold chain. Perhaps for sensitive data, we have this hot chain where at each step of that supply chain, we need to make sure that we are managing the risks accordingly. And that falls under the topic of like data governance and enabling accessibility responsibly. So let's just diving into like what does responsible mean, and like what is responsible AI, because we are looking at this from the lens or like the view of a responsible AI. And there are like a number of definitions in the space. It is, again, emerging, so the taxonomy isn't that set just yet. So you'll see papers or industry best standards published under a number of these different topics if you're looking around. However, this paper at the bottom here has suggested that socially responsible AI subsumes all of these concepts over here. And if you're interested in how they do that, you can look at that paper. I personally, this is my personal favorite sort of high-level heading in the space that categorizes other subtopics. So this is the definition, but don't worry, you don't have to memorize this. So I will just quickly read through it. Social responsibility of AI refers to a human value-driven process where values such as fairness, transparency, accountability, reliability, and safety, privacy and security, and inclusiveness are the principles And I think principles is an important word there, because in very complex systems like our societies, often when we don't have explicit ways of addressing something, much like maybe like an expert system for the nerds here might do, then having principles as a guiding way to address something is, I think, a good approach. So designing socially responsible AI algorithms is the means, and addressing the social expectations of generating shared value, enhancing both AI's ability and benefits to society, is the main objective. That's a lot. So let's look at like a summary of that. So if you're doing responsible AI, first of all, it should be, you have functional responsibilities, so make it work. You have legal responsibilities, so please obey the law. We have ethical responsibilities, so prevent harm and do what you believe is right. And then we have at the top of the pyramid there, philanthropic responsibilities, so try to be a good citizen where you can. And you'll see now everyone and their uncle has their own framework for responsible AI. So because I enjoy meta problems and meta approaches to things, this is a meta framework for developing responsible AI frameworks. So any framework should then be broad, operationalizable, flexible, iterative throughout the life cycle of the system. So don't just do it at the end of the project, do it at the beginning, the middle, and the end. It should be guided, so easy to access and understand, and participatory, including all of the relevant stakeholders. And the point I'd like to make here is that from my experience, often people see responsible AI as like potentially like fluff. But when you're dealing in high-risk spaces, I firmly believe that responsible AI frameworks are the best way to ensure that your product or your service sees the light of day, because it will help you avoid being blocked by regulation or by some harm that you might cause. So the quickest way to really get these things done in a way that is robust and reproducible, I believe to be the responsible AI route. So it makes good business sense, is what I'm trying to get at. So here is one of my top frameworks. I'm not going to go through all of it. I am just showing it so that you all can get an idea of what that looks like. So starting with organizational planning, use case planning, development, and then finally with operationalization. And just looking where sensitive data can creep in and potentially cause harm. There are just like a lot of spaces here that it touches on. So maybe this isn't the best view or model for our consideration. Let's simplify this and consider this like data science stack, where the this section of the pyramid is typically where your data lives, and if you have sensitive data, you'd want some governance processes that make sure that it is not doing any harm. So kind of putting that in a lockbox or a hot chain, and various lockboxes to ensure you maintain privacy and security of that data. But then if it is in this very secure space, how do we get it to our model, and how do we actually get utility out of that data? And that's where I enjoy the use of the word data accessibility. So governance and accessibility are closely related, and I think just two different ways of looking at similar problems. But because we care about making data accessible to AI models for training in this case, I think data accessibility is the right term to use. So, rejigging that to look at our supply chain, what are some of the things that we need to consider? So, because DVT is a technology company, let's think about the technology first. A well-principled way to look at some of the technology you'd want to use is a secure data environments, sometimes also called trusted research environments, but they work on the 5 or 7 if you're feeling bold. Safe principles, so that's safe data, safe settings, safe projects, safe outputs, safe people, safe computing, and safe returns. And in the schematic of a example secure data environment in the healthcare space, you'll see where some of these safe principles would be applicable. So safe data meaning like, is the data itself safe? And safe setting is the environment, so your hardware and infrastructure safe. Ideally, you'd want to be able to like pen test these things or penetration test these things with a red team, and then have a blue team try show them up. And I really like purple teams where people swap roles in those cybersecurity settings, but very often people don't have the budget for that. So using secure platforms, I think, is a good way for the majority of projects. So then also, is the nature of the project itself, in terms of the governance and what the project aims to accomplish, is it safe? When we're outputting things, are those outputs that we make either, at any level of outside of the safe setting, is that safe? And then have the people been vetted, or are we just letting anyone into the space? And the answers to those questions will help you design the system and assess if a system is up to scratch. But it's not only the technology, it's also governance processes. So Dharma is one of the authorities, I guess, on data governance, but it is a very broad space. Their textbook isn't open source, which makes it a bit inaccessible. But if you are able to get hold of it, then I do think it is a valuable resource, as it is quite comprehensive and aligned, especially for like enterprise contexts. But it's not just technology and governance, it's also the law and how all of these things interact. You can see here, it's really only quite recent that Africa has been looking at data governance laws. So this is a great resource. It summarizes the data protection laws across Africa. You'll see that there are still some countries that do not have any laws just yet. And then it's societal trust that we need to build in all of the above, in the law, in the governance, and the technology. If people are going to let you share their sensitive data, they need to trust that all of this machinery is going to be in their best interest. So that this bridge is not going to collapse. So I think we have a responsibility as practitioners in the space to engage with participants or data subjects in education around that. I think it's a very vital part of making all of this work. And a sentiment that I really deeply appreciate is that data moves at the speed of trust. And we'll see there are terms now surfacing or emerging in the space like data diplomat, which I have mixed feelings about. I think it's probably necessary, but I do think we could do a lot to try and avoid needing roles like that. There's a lot of soft power and hard power that data custodians and data stewards get from having data in their possession. So negotiation is a very big part of getting sensitive data moving. Yeah. Just to see where, how this is being looked at, what is the current state globally of data sharing and privacy preserving strategy. So you'll see only very recently, 2023, the US released their strategy on this topic. And while the EU has been fairly ahead with GDPR in 2016 and it being effective in 2018, their data strategy really only came out in 2020. So this is a new enough space to have an impact if you're looking to get into it. But with the EU AI Act, their data and governance clause in Article 10 under Chapter 3 is only in effect next year. So we are, I believe, at a bleeding edge of a topic that I think a lot of people don't pay enough attention to, and I would consider one of the biggest blockers in high risk and AI settings. And what's happening in Africa? So as early as 2014, we had the African Union Convention on Cybersecurity and Personal Data Protection, which is great. This Smart Africa collective has a number of great projects going on. I encourage you to check it out. Again, African Union is doing some interesting stuff, and this Malabo roadmap is a must. Please go and look at it if you are interested in data in Africa. Just to drive the point home about the complexity. So these are enabling data or data accessibility frameworks from the African Union. And there's legal, trust, institutional, public, policy, governance, sovereignty, a lot of buzzwords that I feel help drive home the complexity. And again, remember that this is just one part of your AI project. So good luck. There are, however, a lot of groups that are doing good work. So this is an example from the healthcare space. A canonical example from COVID times was this Open Safely initiative from the UK. If anyone knows Ben Goldacre, they were involved there. They're a supremely sarcastic epidemiologist. But what they were able to do is make accessible in a safe way about 58 million UK patient records related to COVID. And that enabled very rapid risk factor assessments early on in the COVID pandemic. So this had an incredible global impact. And since then, and risk factor assessment being like, if you, how worried should you be given what your risk factors are if you get COVID? And a 58 million patient cohort is unprecedented, to say the least. It's a massive sample. So this speaks to the potential power of making data accessible and unlocking this for various types of analyses. So the Brazilian government is doing some great work. They've got what I think is the world's largest patient cohort at 113 million patients. It's aptly named the 100 million Brazilian cohort. I was actually a principal investigator on a federated analysis with them over the last few years on tuberculosis and syphilis in pregnancy between the Western Cape and their group. They've done some incredible work. Keep an eye on their publications. Elwazi is an African data science platform. Also, keep an eye on that. And here's just a great summary of data centers doing good work. So getting to actually unblocking some practical tips. And I am true to common potential blockers, but we're going to do our best because it's complex and these are very high level. So often the problems will be very case specific or context specific, and just keep that in mind. First and foremost, I think a great place to start with any high risk data project is understanding like the threat model, using a cybersecurity term, or the data risk classification for any data that you have. This is one from Harvard. They've got 5 different classifications, from like the most sensitive at number 5 to number 1 being essentially open source or open access. And what I find this does is it really grounds the project in concrete conversations that address risk directly, while also enabling cross-functional teams, as you'll definitely be working in a cross-functional space to do this, because it's both governance and technology. And this will give your technology team and your governance team a common place to have conversations. So I just find this extraordinarily practical to have as early as possible in a project, and then iterate over time. You don't need 5 tiers to start with. Start with 2. Start with very sensitive or not sensitive, and then work your way up from there. And then this is often what your system would look like if you have data sources coming in with your raw data that you're landing in your data center or your cloud storage or whatever. The big circle being the most sensitive and also the largest set of data. Then as you make that data less sensitive through either de-identification or subsampling, or a number of methods we'll touch on, these data sets tend to get smaller, where you're left with any data that you actually want to make openly accessible often is quite a bit smaller, and the utility is far less than your original data set. So there's always trade-offs every time you progress down this ladder. Also noting that often people want to try and fund open access data, but not data accessibility along various tiers. So I think it's far more prudent and effective to not just try and fund this open data, although that does have an interesting sort of pull effect in the space, but every tier along the way. And that will be for projects like secure data environment projects, because I think you'll get more bang for your buck. So let's start sort of at the beginning of your journey in the space. If you're working on a project, data collection. So just using like health data and financial data as 2 examples of highly sensitive data. You typically get this from like a electronic health record system in a hospital, or maybe your smart tracker watch, or your phone's banking app or healthcare app, or a ATM pay points when you interact with your bank. So just getting it, we need to make sure that all of these things are secure. So this is the first part of the supply chain we have to lock down. And keeping that in mind, I think will help one stop getting blocked. The next step there, when you want to make your data accessible, is the preparation to actually share that data. And often that comes in the form of a data sharing agreement between 2 or more parties. And this can be between data custodians or researchers or companies. There's no sort of limit on who can agree to share data between each other. And there are more tools now that are helping people template this, especially with, and I'd advise using, I do think large language models are doing fairly well at search, discovery, and summary for templating, but our own South African bioinformatics group has put together this templating tool for data sharing agreements. I highly recommend it. And once we've agreed on how we're going to share that data, we then need to transport that, noting, please always keep your data encrypted at rest and in motion. So when it's being stored and when you're moving it between various storage platforms or solutions. And noting that the API standards, interestingly enough, give us an opportunity to do federated analyses. So API standards are often tightly coupled to a particular data model, which then gives us certain assumptions about the nature of the data. In the healthcare space, OpenEHR, FHIR, and OMOP are some emerging standards. In the financial space, BIAN, FDE, and the ISO standards are being used. And to give you an example from OMOP, how this can be used to enable federated analyses, I'm going to look at them just fairly generally. And if we had to look at these data centers, so turning our data sources into data centers, where let's say we wanted to combine data from like very many data centers, how can we do that? Let's say if these data centers are in different countries and data sovereignty is an issue. You can actually sidestep the data sovereignty issue by using systems like Gen 3 where you bring compute to the data. So that's coordinating. This is a system that coordinates remote execution of code and then combining of those results. So essentially, you're offloading the compute to do local analysis in situ or in place, and then combining those analysis artifacts, which can either be just the results of analysis, like if it's statistical, your various distributions that you might get, because when you aggregate the data or the analyses results, there's a strong way that aggregation is a strong privacy preserving mechanism. Or if you're doing deep learning, you can just average your neural network weights. Surprising that works. And I often think about what would happen if you just averaged 2 or more people's brains, but that's a conversation for another time. But that does work. There are some trade-offs, so it's not perfect, but that is what we call federated learning, which is a subset of federated analyses, and is often what people get excited for. So looking at these analysis results and grounding this in a concrete example, the UMOP, we have 3 different organizations that do healthcare stuff. If you align their data models, so making their SQL databases look the same, both in structure and in the vocabulary that you use, so schema standards and like ontology or vocabulary standards, then it allows you to combine the results if you do that local compute, just to be sure that you are comparing apples with apples and not apples with crabs or something strange. This is what those transforms look like, just for interest. I'm not going to get into this, but here's a breadcrumb if you'd like to dig into it. The next common blocker is the storage spaces. So these are the secure data environments, as I mentioned earlier. What are some good things to be aware of is just like base cybersecurity principles. There are lots there. So the 2 that I tend to lean on are principles of least privilege or access and separation of duties, as well as defense in depth. So this is like the Swiss cheese model. You might remember this from COVID. It's a similar thing where it's don't just get immunized. You want to get immunized, wear a mask, and also social distance. So every layer adds some protection, and hopefully each layer will catch like 95% of your problems. And also, as mentioned before, with the risk classification for your data, what is your threat model? Is the juice worth the squeeze? We don't want to put in like too much or too little effort for what our risk might be. So those need to be aligned. Wow. Cool. So here is a, and then just making a note that this least privileges and separation of duties. So having like a data engineer, a research scientist or analyst, or like end user, if that's a doctor, like your data scientist here, and here's a data engineer. So separating out those privileges sort of limits the blast zone to just their scope if human error does creep in, or if there's a malicious actor. But it's more often than not, I think, human error. And then also, when you start a project, start with your research question or your business problem, and make sure to use only as much data as necessary and as little data as possible. Often, managers might ask a data scientist to, here are 3 truckloads of data, find the insights. And just the nature of that approach means that you're already using as much data as possible, which increases the risk for harm. So by just starting your approach with a question or problem helps scope and limit the data that is necessary to use. And it's a very effective method. Here's just a framework if you're interested for that kind of security. Privacy preserving methods, and this is also what a lot of people get very excited by. It is also maybe one of the more technically dense. So I will do a little bit of a deep dive here, and also apology, 1 or 2 of my slides, the formatting was a little bit off with the bulletin, so sorry about that. Bear with me, please. But yeah, it's also a space for like rapid advancement and development. So if you like shiny new things, this is a space for you, and this often happens within the data center. So that's kind of what I'm trying to show there. But it also happens at like various stages. At a very high level, we can categorize these as altering data, shielding data, and like systems plus architecture. And I really love this comment by the author. It says, these categories are based on the author's analysis of these methods. The author acknowledges that there are multiple ways to group these technologies, techniques, and processes. And if you get into the space, there really is not a mature term like nomenclature or set of terms. So there are a lot of different ways to slice how we group these. It can be a bit disorienting when first entering the space, so just be aware of that. Here is one way to look at it. So we have things like differential privacy, federated learning, which is the neural nets approach that we mentioned, secure multi-party compute, and homomorphic encryption. All of these have their trade-offs. Differential privacy is kind of like injecting noise to allow you for plausible deniability, let's call it that. So if I inject noise, then in like a survey, if I say every 1 out of 100 survey participants, if we're saying you like cats or dogs, we just randomly change 10 or 1 or 10% of them to like cats or dogs at random, then re-identification becomes hard because we have perturbed that data. Secure multi-party compute is one of the most mature approaches I've seen in the space. And if you're looking for something that's scalable, I recommend looking at that. Homomorphic encryption is a very new technology. It's amazing, but it has very high compute costs or like overheads in terms of runtimes. So those algorithms still need to be worked on, but it does provide like mathematically provable security. And an example of what that might be like, if you have a healthcare app, you take a photo that might be sensitive, you can send that encrypted photo to a service provider. Without decrypting it, they can do compute on that encrypted data and give you an encrypted answer, like a diagnosis. So they won't know what diagnosis they've given you, but they'll know from their like testing and training spaces that they have like 95% accuracy or 100% or 99% accuracy, so they can be confident that whatever blind diagnosis they've given you, that their model is working. But I think it's quite incredible that we can have options to interact in that way, even if these aren't mature. And I think in terms of emerging technologies, keep an eye on that. Here's just like a couple more. Synthetic data is important. Zero knowledge proofs, also very new and quite exciting. I'm not going to dive into that, but just mentioning these. Again, another view, just for interest. So one way I try and like make sense of all of these different ways is to think about it in terms of the supply chain. So if we have data coming in from these raw data sources, we have techniques that help with like integration and techniques that help with, or methods that help with publishing. And mining is another term that tends to come up. So what do I mean by this? So integration are things like data linkage. I'm running out of time, so I'm going to be quick. This is a way to do data linkage in a privacy-preserving way to integrate that data. Then data publishing, we've already been talking about. That's like de-identification, and you can publish, you can do data publishing within your organization to a secure environment or like to open data. And then data mining, often what they mean there is you're not getting data as an output, you're getting some kind of artifacts like learned weights. Here's the flow that you'd typically use: know your data, de-identify your data, apply anonymization techniques, compute your risk, manage your risks. So what does that look like? Quick way to look at a glance: if you've de-identified your data properly, this is just here for a resource. Here are more in-depth technical measures. So I'm going to very quickly just breeze through, I'll say like the top 3 measures. So again, this is a measure. So this is not de-identifying something. This is saying once we've de-identified it, how do we know that what our risk is? And often this loop over here is what we're interested in there. So I'm just going to talk about that for a moment. So the top three are K anonymity, L diversity, and T closeness as measures of how de-identified your data is. And these techniques here we can use to drive these numbers in the direction, or these metrics in the direction that we want. So K anonymity, basically this is just saying if it's 1, it means that you are uniquely identifiable. And if it's like 5, then there are 5 other entries in the data set that could be you. So you use like plausible deniability, and this is one of the best places to start, and it's one of the easiest ones to do as well. And these are some ways you can go about doing that. L diversity is just adding variety. So again, sorry, I don't have time to get into this, but for those of us who are interested, please do take a look. T closeness, again, is one of the ways that we want to address that. And each layer of this adds something. So it prevents isolation, prevents homogeneity, prevents distribution skews. And this is kind of what that would look like as in your day-to-day. And for different contexts, these are the typical values that you'd like to get for these. And you kind of stack these in complexity, adding them as is needed. Noting always that your data privacy versus your data utility are often being traded off. I would say always being traded off. So either you have good data privacy and low data utility, or low data privacy and good data utility. And this ideal solution seems a bit out of reach, for now at least, but not impossible. Just a note from this great book on site reliability engineering for ML. It's a fairly new book. Noting, don't anonymize yourself. 87% of all US people in this particular study were re-identified with 3 pieces of information: gender, age, and zip code. And there are a lot of good examples when de-identification actually fails. So I'm very skeptical of sites that say, oh, don't worry, we've anonymized your data. Like that to me, anonymization is so case specific. There are no general solutions yet. Be skeptical. Yes. Now again, just driving this point home with classification, and I am out of time, so this will be super quick. Open mind, look at these courses. They're great. They pitch them at like executive level and like advanced technical levels. They got 60 hours on the foundations of it. So please check it out. They're one of the best groups in the space working on also building tooling. So PySwift is a Python library you can use now. It's got thousands of stars on GitHub. If you want to get started with something, I've got a open mind Swiftbox suite, which is a more comprehensive group of tools if you're looking to do enterprise products. Acknowledging in that this is complex and we're not going to solve it in a top-down or bottom-up way, but rather sort of at every level in between. And we're seeing approaches like this in the world, like the One Health approach from the WHO, that have acknowledged that we can't just do stuff top-down. We have to really get participatory input at multiple levels if we want to solve these complex problems. And just some emerging solutions. These are my own sort of niche personal interests, but if you're interested, there are some things coming from like the blue sky space, as well as the solid pods and activity pub space, that are doing some really interesting stuff in putting you in the driver's seat of your own data. So solid pods is an initiative by Tim Berners-Lee, who some might know wrote the WWW, or World Wide Web protocol, initially at CERN, and this is their response to what they believe is not the way they wanted the web to go. So keep an eye on this. Blue Sky is an alternative to Twitter, and so is Mastodon. They've got these things called personal data servers, which empowers you to have your data in your governance. So here's kind of like the progression of what this looks like, basically saying that your service provider should only control your app, and you should be in control of your data. Activity pods and personal data servers are solving the same problem, and I see that these two are going to be competing for users soon. Activity pods is a mix between solid pods and the activity pub protocol, which is Mastodon, again, another Twitter alternative, but it is both of these are good examples of like products that are in the wild that have millions of users and sort of proof of concept that these approaches are working. Another emerging solution from OpenMind is this concept of attribution-based control, basically saying, it's just like saying cutting out the middleman is the easiest way to describe it. And essentially, instead of saying let's train an AI on all of your on all data and then serve that, essentially giving every person like their own route with an AI to the data subjects or wherever the data lives. So an example of that might be medical data. If you're like medical students and you're trying to get information for all this, it's just really cutting out that middleman. And my own aspirations in this space are an initiative that I've recently started this year. So within my community building space, this is a new, I'm going to call it a community of inquiry. So at this moment, it's there just to start a conversation, but looks to build open source business models and technology stacks that African entrepreneurs can use to help us, protect against US or European encroachments on trying to solve African problems that I think we are well positioned to solve ourselves. And the reason that I am very bullish on the idea of cooperatives, for those of you who aren't familiar, they are democratically run organizations. We're seeing a big movement globally in the platform cooperative space. So alternatives to Uber, like a co-op driver in New York, where drivers are democratically sort of co-owners of the platform itself and are earning between like 15 to 20% more than their Uber counterparts. So I'm out of time and I've got maybe 30 seconds left. I will wrap this up in a moment. This is my last slide. The idea here is, from a starting point to try and aim for a federation or like a collective of African data cooperatives where we're all using similar or like forkable like code business models, where I imagine it could work where a particular country, maybe South Africa, starts the initial cooperative with their open business model, then essentially creates their own customers and provides services to both their members who are individuals and other African cooperatives. Yeah, and again, the reason I think cooperatives are a good option here is that they're, in terms of, let's say, a data diplomat, I see them as like the ultimate data diplomats. They are fairly politically neutral in that, and they're enabling. So if you think of public ownership as a solution to get social alignment in your economic activity, and private ownership as a way to really push forward innovation in spaces that are higher risk. I mean, that's oversimplified, but I see cooperatives as a in-between solution where we can tune both social alignment and an ability to innovate. So I think they're a great candidate. And this technology stack, you can start one of these tomorrow. Tools like Nextcloud, the technology is there. We just really need to develop an African model. And that's all for myself. Sorry for going a little bit over time, and keen to hear back from the audience. Thanks, everyone.
Great stuff, Chris. Thank you for that. And I think that's definitely brought some awareness to folks to kind of go, there is a whole domain and focus here in terms of the consideration of data, the sensitivity of data, privacy of data, control of data, that is in the space that needs attention. And as organizations progress from the typical easy AI bits, stand up a bot, give it some basic content and it answer questions, and they start looking for the value driving use cases, which are going to be dependent potentially on sensitive data. They're going to have to give more thought to this space and have to give consideration to how they mitigate the risk. Perhaps just as one question to answer, Chris, is for organizations out there that don't have a Chris, as we are fortunate to have, where does that role sit within the organization? Who's the likely candidate to take this up as a topic of consideration, give focus to it, and start to drive awareness of this within the organization? even before they start to think of the technology implications and the use of AI as the solution mechanism?
Sure, thanks. I think that's a superb question. So thanks for that initial feedback. I think anyone who finds themselves close to the data is likely well positioned. I mean, I don't think there are necessarily requirements. I think my general answer would be, if you're interested in it, then do it. But if you're a data engineer, or if you're already close to data governance in some way, or if your company has no data governance and is like a startup or maybe even an enterprise and they haven't gotten to that just yet, then and you're feeling concerned, I think, or inspired, then yeah, just starting to have those conversations is probably day one. Try identify the relevant stakeholders, understand who the people are that are either data owners or data stewards or custodians, because they're the people you're going to have to negotiate with to try and make data more accessible. I think having a good understanding then, or investigating as you go, what the regulatory blockers are in terms of the law is a great next step as well. So saying, well, this is what we might want to do. And I think just starting with a project or even a small project, I'm very pro project-oriented like initiatives in terms of a way to ground and coordinate attention across the organization. And even if that's a very small project, it can be like a pilot project, it can be a proof of concept, POC. But I do think that the motivations are all there and the business value is absolutely there.
Fantastic. And again, Chris, thank you so much for sharing your time and expertise today. That has been most insightful. We really appreciate your time and expertise.
Thank you.
A global software company rooted in South Africa, with reach across the UK, Europe, and the Middle East. We bring together architects, engineers, designers, analysts, collaborating as one team to build systems that drive outcomes, not just outputs. Because the future doesn't belong to those with the most data, it belongs to those who know how to use it and build on it fast. From enterprise apps to Gen AI bots, from cloud solutions to product strategy, we deliver digital with direction. Built right, built custom, built for change. So let's break the limits of legacy systems. Let's create things worth using again and again. Let's turn slow into agile, complex into simple, idea into impact. Technology should serve purpose, solve problems, move business forward. At DVT, we believe great software is more than code. It's strategy, design, and execution. We work with companies ready to build boldly, to scale smarter, to reimagine what's possible through custom technology. Software is everywhere, but its power is only unlocked when it's designed for people. DVT is the partner behind your next transformation. Because when software works, so does everything else. This is what we do. This is DVT.